When deciding whether or not you have a quadratic function, in contrast to your linear function, you're going to see a degree of 2 this time. So you're still going to look at the degree, which remember is the exponent, and the highest exponent is going to need to be a 2. So when your highest exponent is a 2, then your function is quadratic. When I look at this quadratic function in vertex form, the squared, the degree 2, that exponent of 2 is outside the parentheses, but what would happen if I multiplied x minus 3 times x minus 3, the first thing that happens is we get x times x is x squared. So in vertex form, we are degree 2. P of x is showing me the squared, that degree 2, the exponent of 2 on my variable. So, and it's the highest exponent. I also have an exponent of 1 here, but as long as your highest exponent is 2, you are also quadratic. This one happens to be in standard form. And then this quadratic function in factored form, also similarly to that vertex form, so this is our factored form. If I multiply x times x, the first thing that happens is I end up with that x squared. So these three functions have degree 2, which means they are quadratic. So I would say this function is quadratic because the highest exponent the degree of my function is 2. If I'm looking at a graph, I know that my function is quadratic because its graph is a parabola. Remember, the parabola is that curvy, almost a U shape. It's either concave up or concave down. It's either got a vertex at a minimum or a vertex at a maximum. And we can say the function is quadratic because its graph is a parabola. And then finally, if I'm looking at a table, this time I'll take the differences, but I'm going to have to do it twice to notice that they're constant. So again, x values are all in order, -2, -1, 0, 1, 2, 3. And we'll do our differences. 17 minus 14 is 3. 14 minus 13 is 1. 13 minus 14 is -1. 14 minus 17 is -3. And 17 minus 22 is -5. And when I subtract them, so the first differences are not constant. So I'll try one more time. 3 minus 1 is 2. 1 minus -1. Notice it's minus a negative. Always subtract for those differences. -1 minus -3 is 2. And -3 minus -5 also equal to 2. So I took my differences a second time, and now I can see that they're constant. So this function is quadratic because its second differences are constant. So, in total, we have a quadratic function if we are degree 2, looking at the equation, if our graph is a parabola, or if from a table we can show that the second differences are the same, they are constant.